An important component of research in the McQuaid group is developing new materials for our catalytic processes. And my role in this is using microfluidics to make some of these materials. Microfluidics is the process of using very small channels on the order of 10 to 1,000 microns to produce small droplets. Traditional microfluidic devices are pretty difficult and expensive to make and to operate. And we decided to make a simplified version of microfluidics using just tubing, needles, and syringes. And what this looks like in operation is this so-called continuous phase is pumped in here, and a dispersed phase makes droplets from this other syringe here, and both syringes are run with syringe pumps. And what this looks like in operation is right here. This is one of our T-junction devices making droplets, and you can see they're very monodisperse, produced very regularly. And how we make materials out of these is to put various monomers in either the droplets or the continuous phase and then polymerize them. Some examples of these are polyamide microcapsules, hollow hierarchically structured organosilicon microcapsules, polyurea microcapsules, and we can also do UV photopolymerization of acrylate droplets to make solid acrylate microspheres. Now we've taken the initial T-junction device that we started with and have evolved that into a coaxial flow focusing device where the continuous phase now comes in from both directions. The dispersed phase again enters via a needle, and all three go out the same outlet needle through this small orifice. And this new device allows us to make much smaller droplets than the T-junction. And in addition, we can make biphasic Janus phase microcapsules, or solid microspheres rather, where we have a red dye and a blue dye on each half. Also, we can combine the flow focusing device and the T-junction in series to make complex materials such as these microdroplet in microcapsule or microparticle in microcapsule devices, materials, excuse me. So the goal now is to take the microfluidic devices and make some of the catalytic materials made by others in the group that you can hear about on the website, and make them in monodispersed form so we have more control over the catalytic capabilities of these materials. For example, the porous polyacrylate microbeads that we use in our flow-through reactors, and the microencapsulated catalytic linear polymers that we hope to use for multi-step one-pot syntheses.